So we did this part, correct? Uh, I forgot to mention one important point while I was dealing with those unit, and you will see in the future. It will be in the gravitation unit. What is the work? Okay, you will have work in the form of the gravitation unit. Today's date 11 12 2025. So when you have gravitation unit, Anvita, what is gravitation unit? Anvita, Anvita, are you there?
No, sir, she is not.
Okay. So Barinder, what are the gravitation unit? These two are the gravitation unit, kilogram meter or gram centimeter. You must have seen in the gravitation chapter or other topic, right? सबने देखा है ना
Yes,
ये?
sir.
Yeah. So when we are dealing with the kilogram meter, so this is the SI unit. It is the gravitation unit of Earth in SI system. And this gram centimeter is in CGS system as it suggests, correct? But we have to convert this into the joule form. Then how to do this? You know, work done is equal to F d cos theta. Cos theta does not have any unit. So same way here, 1 kilogram meter will be equal to 1 kilogram weight. 1 kilogram weight. And this will be equal to 9.8 Newton, and meter is meter, correct? And it will be equal to 9.8 joule. So really important कि 1 kilogram meter will be equal to 9.8 joule. Now tell me guys, you have seen such type of question where you have to convert a unit.
Yes, sir.
Yes or no? Yeah.
Yes, sir.
Same way you can convert gram centimeter into the same way. How? Example, 1 gram centimeter is equal to 1 gram weight multiplied by 1 centimeter. 1 meter. Okay, this will be equal to 989 multiplied by 1 centimeter. That's why 1 gram centimeter will be equal to 980 ERG. And you know how to convert your ERG into joule. 10 is to the power 7. Correct? 1 joule is equal to 10 is to the power 7 ERG. You already know this from the previous topic. 1 joule is equal to 10 is to the power 7 ERG. Yes or no, guys?
Yes,
Yeah. So let me give you a question from this. A lawn roller has been pushed by the gardener to a distance 30 centimeters. A lawn roller is pushed by a distance 30 meters. Pushed. What will be the work done by him if he apply a force 30 kg weight in the direction inclined at angle 60 degree to the ground? Angle 60 degree to the ground. This to the ground is really, really important. If this is the situation, you have to calculate work done. Make it fast.
सर जो केजी है उसको कन्वर्ट करना है जॉल में पहले।
हाँ हाँ, सेम वे में केजी वेट ऐसा यूनिट है और उसको हमें न्यूटन में कन्वर्ट करना फोर्स को।
ओके।
मतलब केजी वेट इज इक्वल टू न्यूटन, like you have to convert into the Newton form. Done.
So,
Yes, Jordan.
work, I got the answer.
What is your answer?
4.4 into 10 to the power of 3 joules.
4.4 and 10 is possible. I think approximately it is correct. Answer is, we know displacement is 30 meter. Force is equal to 30 kg weight, which is also equal to, you can multiply with the 10. You can take 300 Newton. And angle is 60. Just simply multiply. Work is equal to FD cos 60. 300 multiplied by 30. What is the cos 60 value? 1 by 2.
Yes, 1 by 2. Sir, I did like what, 30 into 9.8 because G you can
You
take
know, G value you can write in both
as
form.
10 or 9.8. Huh?
So, next question. Huh. So, question is, a cyclist come to skidding stop in the 10 meter. Cyclist stop in 10 meter. During the process, force on the cycle due to road is force on cycle due to road is 200 Newton, and directly opposite to the motion, of course, opposite to motion. Then you have to calculate how much work does the road do on the cycle. So work done by road. First question. Second question. How much work is done by the cycle on the road? On road. Calculate this. Think about the if cycle will stop in 10 meter, So what is the reason behind this? Friction, right? If you are applying force in this direction and if you are applying force in the backward direction, but body is moving displacement in this direction, this is force, this is displacement. What is the angle between them? 180. What is responsible for stopping the cycle? Frictional force. So this is frictional force. Understood? This is frictional force. In this frictional force, how to calculate work done by road on the cycle? The force into displacement
So we
into
take
force.
cos 180, no? So cos 180 will be
Yeah.
minus. So
So
minus
force value
2000.
is 200, displacement 10 meter, and this is what is the cos 180 value? Minus 1.
Minus 1.
So if it is minus 1, it will be minus 2000 joule, which simply says that the backward direction force. Correct? Now you have to calculate what is the work done on the road.
So can we apply that logic of equal and opposite force? Because
Yes, Newton's third law
this,
is applicable here.
so then that will also be 2000 joules. Because if work by road on cycle will be minus 2000, work on
Hmm.
road will be 2000. That's what I feel.
Hmm. Ah, 0.
How, sir?
How is how is that possible? Because in this case, if you see the work done, so work done you are calculating like you can apply Newton's third law. Every action
Okay,
have equal
so because there's no change in the road, there's no distortion of shape,
displacement. Yes. So
displacement.
force will be same to 200 Newton, even in this case, because equal and opposite force. But when you see work done on the road is not moving. Cycle was moving. That's why there is some work done. But road is not moving. In this case, displacement is 0. And if displacement 0, work done will be 0. Any doubt?
No doubts here.
Anybody have doubt?
No, sir.
Very good. Then solve next question. You have a force of 3x square I cap plus 4j cap. Okay, in Newton. And this is the force act on the particle. How much work is done on the particle if it is moving in the coordinate in which this move is 2 meter and 3 meter, 2, 3 meter and 0 meter. You have to calculate work done. This is second question. Third question. In this case, if you solve this question, force is already given. But if you see coordinate, uh, x initial and y initial is given, x final and y
7
final.
Joule.
How much? 7 joule.
7 Joule.
Yeah, 7 joule is the correct answer. So if you want to calculate work done, you know there will be force into x with respect to dx from x initial to x final. Correct? Same way, in the y-axis, Fy dy from moving y initial to y final. Correct? Y initial to y final. So, force value you already have. If you do integration, so what is the force value in the x-axis? 3x square. Correct? This is 223. See, this x initial is 2 meter and x final is 3 meter. Correct? With respect to dx. Plus, in y-axis, 4j cap in the case of force, dy. What is the initial value? 3 meter. And what is the final value? X 3 and y final 0. 3 to 0. Okay. Now you have to do integration. What is the integration of 3x here? 3x cube by 3. So 3 will be cancelled out. Correct? 3 will be cancelled out. 2 to 3. Plus, what is the integration of 4? 4y from 3 to 0. Make sense? 4y from 3 to 0. This cancel, y will come out. If you put 3 value, it will be 27. If you put 2 value, it will be 8. Correct? Plus, if you see here, final value 0, initial value minus 12. So what is the answer? This one is 19 minus 12, 7 joule. Yes or no, guys? Was it difficult question?
No, sir.
When you see question, initial coordinate to final coordinate, f with respect to x, f with respect to y. Okay, next question. Question number 4 is a woman pushed a truck on the railway platform which has a rough surface. She applied a force of 100 Newton over a distance of 10 meters. Thereafter, she gets progressively tired and her applied force reduced linearly with the distance to the force reduce linearly to 50 Newton. Total distance covered by the truck is total D is 20 meter. Plot the force applied by the woman and frictional force, which is 50 Newton. Force applied and frictional force 50 Newton. Calculate the work done by the two forces over 20 meters. Work done by the external force, work done by the frictional force over 20 meters total. Then C answer. You know, up to 10 meter, force is positive. Work done will be positive because work done is there in the direction of force. Correct? 100 and 10. So if we want to draw a graph,
750.
750 total work done.
हाँ.
Total, correct. 750. So how to calculate example? We are doing this. This is the graph. This one is displacement. This one is force. Okay. So initially you applied 100 Newton, then 50 Newton. So we will take only 2 units, 100 and 50 Newton force. Correct. And friction is will be minus 50. So we'll keep it down. Minus 50 by friction. So what will happen in this case? Here you have two distance. Let's take 10 meter and it's double 20. Okay. So in first 10 meter, force was 20 Newton. Like this. Then it will reduce to the 50 Newton. That's understand? As simple as that. This will be the graph. First, 100 Newton, 10 meter distance graph. Then force linearly reducing from 100 to 50. Okay, this is the graph. You can make this dotted line and this. Okay. You know frictional force act in the opposite direction. Frictional force act in the opposite direction. So frictional force will be this and frictional force will be same throughout the journey. Correct? This is for the frictional force. Remember this is for F friction. This is for normal F. Correct? Now if you understand this, you can calculate work done. Work done by the work done by the upper force, like external force, and work done by lower force, that is friction. How to calculate total area? If you want to calculate work done for external force, uh, area under the graph. And when I'm saying area under graph, it means this rectangle and this trapezium, this total area. If you say this is A, B, C, D, E, F, so it will be area under A, B, C, D plus area under C, E, F, D. Then you will get the answer. What will be the work done by the friction? Lower area. It will be uh, F, G, H. So it will be the area under AFGH. You know, upper work done will be positive, lower work done will be negative. How to calculate lower work done? Very easy, because in this case, force into displacement. Force is minus 50 Newton and displacement is 20. It will be minus 1000 joules. Correct. Here, if you take for ABCD, what will be the work done value? Easy, just length and width. Length is 10 meter, width is 100. So 100 multiply by 10, 1000 joule. This is for ABCD. Area under CEFD, trapezium. Correct. This is trapezium. And how to calculate area of the trapezium? 1 by 2. Both sides will be added. One is 50, another is 100. Multiply by the base, and base will be the 10. Yes or no? Any doubt? So it will be 750. And if you don't understand this, you can calculate this trapezium separately. Example, first you take lower rectangle, then you take upper triangle. Add them, you will get answer. Right? How to calculate the area of this? This is 50. This one is 10. So what will be work done in this case? 50 multiplied by 10, 500 joule. How to calculate area of the triangle? You know, area of the triangle is half base into height. Base is 50, 100 minus 50, and height is 10. What is the answer? 250. Still, you can get answer 500 plus 250, 750. It will be easy for you. Rectangle plus triangle. Understood, guys?
Yes,
So
sir.
this answer will be uh, previous was 1,500, 1,750. So, so plus 1,750 and minus 1,000. Understood, guys? Do anybody have question?
No, sir.
No, sir.
So this was the question where you will not get direct question. Direct graph become easy. You can calculate the area under the graph in case of problem, right? But here theory is given, one statement, whole statement is given. You have to first draw graph. For rectangle, it's easy. For trapezium, rectangle plus triangle. Okay. So we did four different variety of question where graph, one thing, second thing, the integration part, third thing is two force acting on each other, and fourth was very basic FD cos theta. Correct. So we got the variety of questions. Understood? Next topic is conservative and non-conservative force. Though it is a very small topic, but still we have to do. And this word is very common throughout the different chapter. What are the conservative force? What are the non-conservative force? By the way, Arey, what happened to both of them? By the way, guys, I have news for you.
Yes, sir.
Very soon I'm getting married.
We know February something.
February something. When?
You told someday in Feb. That's all we remember.
That's so. Good
When
afternoon,
did
sir.
I tell? Good afternoon, Sinhmar.
You told me.
Personally,
Yes, sir.
okay. So it is 5th Feb, guys. Okay.
Yes, sir.
So
Congratulations,
plan.
sir.
Thank you. Congratulations is not enough, Anvita. All of you have to guys come with your family, and it's not formality. I'm telling in advance, so you can plan accordingly.
Please tell my dad, sir.
Hmm?
So
I'll
where,
tell him also. What, Anvita?
like, where are you getting married? Like,
Like,
Haryana, proper
yeah.
village.
How do I
Yeah.
reach there? That is the question. I'll be somewhere in Kerala.
Yeah, for 2, 3 days you can take break. I'll ask your parents.
So will you be calling NFC students?
Yeah, I will call most of people because this is business.
Yeah, yeah.
You know,
So
I
you have
have
to
business
sponsor
mind.
our travel,
I'm
train or flight or
expecting money
bus.
from you. That's why I'm
So
calling
we'll bring
everybody.
gifts. We'll give gifts. That is no doubt. But you have to sponsor our travel, bus,
Sponsor a
train, flight, anything.
man, then I will be very
Okay,
trouble.
I will figure something out, sir.
Yeah, but see, it is fun to attend marriage in proper village of Haryana. It will be very simple marriage. I'm not going to do fancy, but it will be fun for sure. You will get a lot of respect. There will be people behind you. Okay, Jordan, Marinder, Pratigya, Chandana, Sania, do you need Anvita? Do you need anything, ma'am? Do you need anything, sir? Like that. You'll get a lot of respect and a lot of attention and a lot of fun music. Understood?
Yes, sir. But how do we come there is the question.
I will talk to everybody's parents. Okay. So it will be fun because see, for next 2 months now you can focus on the exam.
Yeah.
You will be tired by then. You need a short break of 2, 3 days. So come to marriage, enjoy, settle down in 1, 2 days, and then again we'll boost up. Okay. That's why I'm telling you, I'll call your families. So accordingly you can plan because marriage card will be distributed after long time.
Yes, sir.
Sir, आपकी शादी
हाँ मेरी शादी
कब है सर?
सानिया
Yes, sir.
सदमे में है प्रतिज्ञा
Yes, sir.
नहीं सर, खुशी की बात है।
अरे मैं कह रहा था कि प्रतिज्ञा सदमे में है क्योंकि जो एसवीएम की स्टूडेंट है लाइक स्टूडेंट फ्रॉम
हाँ सर,
बरहमपुर
वो
दे
तो होना ही है।
डोंट नो कि व्हाट इज दिस आपकी तो पहले नहीं हो चुकी थी शादी मैडम ने नहीं बोला था है ना प्रतिज्ञा
सर मन में तो बहुत सवाल है।
पूछ लो फिर आज तो पूछ ही डालो देखा जाएगा
मैंने अभी नहीं, अभी क्लास
ठीक
वरना बाकी लोग मुझे बहुत सारे श्राप देंगे।
है नहीं नहीं सर आप तो नहीं देंगे बट be mentally ready for this read well so your parents don't feel it is a wastage of time. Good thing is because of you guys, I made plan in the early Feb. Actually, they gave me date of 23rd of the Feb. Okay, it is too late according to the NEET student. So this will be the perfect time. After that, you will have almost 3 month, proper 3 month for the reading, and intense 3 month. I will take uh, more session of the discussion of every paper. Okay, let's come back to the force because this conservative force word we use at multiple places, right? So, what is the conservative force? A force that depend only on initial and final position, depend only on initial and final position, not on the path. Initial and final position, right? Not on the path. And remember, all of you have to make notes during the class and send me just after the class. Okay, every single person. And this time I'm damn serious. If you don't make notes during the class, I will not allow anybody to attend next class. And I'm damn serious, very serious. I'm telling you now only. So make sure I'll send PDF just after the class. Make notes, not just after the class. You have to make during the class, whatever I am doing, whatever extra point I'm adding, everything. Okay. So not on nature of path. Doesn't matter. Example, if you go from A to B, whether by this path or this path or this path, work done will be same. What is the reason? Because we know work done is equal to force into displacement. And displacement is also conservative. It means displacement between A and B remains same. You go by whatever path, displacement remains same. That's why force is conservative nature and work done in this case is by conservative force. Any doubt? Example, gravitation force. Gravitation force, we will study in gravitation chapter, is the conservative force. It depends only on the initial and final position. Okay, that's why work done will be also conservative in this situation. But remember work done only by conservative force because sometimes there is work done by non-conservative force also. Remember this. Okay, example friction. Friction is not conservative force. Its value will vary in every situation because force is changing. Understood? Yes or no?
Yes,
Yes,
sir.
sir.
Yes, sir.
That's why net work done by the body in moving a round trip will be zero. Example, if you go from A to B like this and work done is plus 100 joule, then B to A, because depend upon the initial and final position, it will be minus 100 joule. What will be the net work done? Zero. Make sense? Any doubt?
No, sir.
Sir.
No, sir.
Okay. Move to the next part, non-conservative force. Now you can imagine what will be the definition. Sania, what will be the definition of non-conservative force?
Sir, it does not depend on the initial and final position.
It
It
does depend
depends
on
on
initial and
the
final position, but it also
path
depends upon the
followed.
path followed.
Yes, sir.
It depends on path followed. In case of conservative force, does not depend upon the path followed. Okay, so this is non-conservative force. Example, if you take same A-B situation, you go from A to B like this, you go like this, and then there is this. This is path 1, path 2, and path 3. In all three situations, work done will not be same. Work done in first is not equal to second, is not equal to third. Here, 1, 2, 3. Work done in all three will be same. Understand? Now you will ask us that tell us what are the force where it is not same friction. One of the best force, frictional force, its amount will change. Correct? And almost like frictional force, it is viscous. Anvita, what is the difference between the frictional force and viscous?
Sir, I'm not sure.
Vandana, Chandana,
Yes, sir.
what is the difference between the frictional force and viscous force?
No, sir, I'm not.
Jordan,
So viscous force is like the friction, like it's not friction. It's I don't know to explain it, sir, but I understood like the difference between it.
you understood, but you can't explain what is this.
It's related to liquids, but then have to look. I don't have to describe it. That's the thing.
But you
There's a
have to.
difference when it's like
Array one friction is present between the two bodies,
two
solid and
bodies,
viscous
but
and liquid.
viscous
As
is like throughout completely the whole
viscous is
liquid.
liquid
It's for fluids,
in
no?
liquid. What, Anvita?
Viscous one is for like fluids, right?
Yes, that's why in mechanical property of fluid we have viscous force, viscosity. So friction in solid and viscosity in fluids. Okay, so we have to calculate work done due to the frictional force. So let's take one situation. Example, you have a mass M. You are applying some force F on it, external force F. Then you know definitely there will be frictional force act in the opposite direction, correct? But displacement is zero. What will be the work done in this case? Work done by frictional force. Parinder,
0.
zero. Because displacement is zero, that's why it is zero. Correct? So we know in this case friction is more than the external force. That's why body cannot move. Correct? Or you can also say in the same way कि if friction is more than that, so mu as static friction is more. Correct? Or same way friction is lesser than the static friction, and instead of this normal, you can write mg. Why I'm writing? Just practice and revision of the friction topic. Correct? कि friction is equal to nu n, or normal is equal to mg. Why? Normal upward direction, mg downward direction. Okay, this is first case. Second case. In case of second case, when you apply external force is greater than the frictional force. Example, here you have mass M. You are applying force, there is a friction in the back side, but there is some displacement in this direction. So, Pratigya, what will be the work done by the friction? Pratigya,
पता नहीं।
negative, because see, your body is moving opposite to the friction side. That's why here work done will be minus nu mg s. Sorry. Understood? Why? Because this part nu mg is what? Frictional force, d displacement, but negative sign. Any doubt?
No, sir.
No, sir.
Yes. One more case. If one body is present above other, then work done because of the friction could be negative also. Because most of time we assume friction act in the opposite direction, so it should be negative only. But sometimes it can be positive as well. Example, if you have same mass M, but this is body B, there is one more body A over B. Okay. So if you are applying F force on it, so what will happen in this situation? You can take separate diagram. This is A. You are applying external force, and friction will act in the opposite direction. Correct? Here it will be kinetic friction because body is moving with this displacement. Okay. But at the same time, if friction is acting in the backward direction for A, for B, friction will act in the forward direction in the same amount. And here displacement on this side. Now tell me, Sania, work done in case of friction for A and work done for B. Sania, she is not there.
Yes, sir.
Huh. Work done by the friction on A, work done by friction on B.
So work done by A will be minus mu s into mg into d.
Minus nu s mg into d. And on case of B, plus. Why? Because both friction and displacement on the same direction.
Yes, sir.
This topic is all about the direction between the force and displacement. And everybody understood this?
Yes, sir.
Yes, sir.
Yes,
Great. If you did this, how many questions we did before? 4. So fifth question. A, I will write complete question. Keep on writing. Wooden block of mass 1 kg is pushed up a surface inclined to horizontal at angle of 30 degree by a force of 10 Newton parallel to the inclined surface. Okay. The coefficient of friction. I will not give diagram. Remember, you have to draw diagram first between block and incline is 0.1. If the block is pushed up by 10 meter along the incline, calculate. First thing, work done against gravity. Second, work done against force of friction. Work done against friction. And third, acceleration of block. Acceleration of block when it move upward. Read carefully.
फर्स्ट वाला 50 जूल
50 joule. Okay.
उसके बाद 8 समथिंग कुछ आ रहा है 8 पॉइंट समथिंग 8.6
Correct. And acceleration. First of all, make diagram. You have incline at angle 30. So this angle is 30. You have a block of mass 1 kg. Then you know
थर्ड
mg
वाला
will
नहीं हो
act.
रहा
Okay, mg. Then here you will have angle same 30. Correct. I will write theta because it is 30. So it will be mg cos theta. And opposite side it will be mg sin theta. Above you have normal reaction and you are applying external force here because it is moving in the upward direction. Correct. So this is the diagram. First question is you have to calculate work done against gravity. So what is the gravity downward direction? What is the force? You know force into displacement. Here force value is equal to mg sin theta. And into displacement, what was the displacement? 10 na? 10 Newton force, 1 kg mass, angle 30 degree. and this. I think there is a displacement also. 10 meter displacement. Okay. So all these values are given. So mg sin theta into d. What is m value? 1, g 10, sin 30 value 1 by 2, and displacement 10. So what will be the answer? 50 joule. Done. So first part was extremely easy. Second part, against the gravity, sorry, friction. Against the friction. So friction multiplied by displacement. What is the friction? Friction value is equal to nu n into d. What is nu n value? Nu same n value is equal to mg cos theta y, because according to this diagram, n value will be equal to mg cos theta. They are opposite to each other. Correct? So n value is mg cos theta multiplied by displacement. Now you can write all the values. Nu value 0.1, m1 g 10, cos 30 value
Sir,
root 3 by 2, displacement 10. Correct? So 0.1 cancel with this 10, 5. So 1.73 multiplied by 5. So 5 3 is a 15, 36, 3, 5, and 8 points. Okay, so work done by the friction is 8.65. Any doubt, guys, up to here?
sir, acceleration, I got the value.
But
It's close to 4.1 meter per second square.
okay, good. Any doubt, guys, up to here?
No, sir.
No, sir.
Last, third part, acceleration. You know acceleration in the upward direction. When you are applying force in the upward direction, this is the acceleration in the upward direction. You have to see what are the force acting in the upward direction, force acting in the downward direction. Correct? If you are moving up, then force acting in the downward direction is friction and mg sin theta, right? Yes.
Yes, sir.
So if you see ki upward direction is the force, downward direction is mg sin theta,
सर हमें इस
gravity.
केस में फ्रिक्शन कंसिडर करना है या नहीं करना है?
बिल्कुल करना है, तभी तो यहाँ पे वैल्यू 0.1 दी है, न्यू की
यस।
वैल्यू, है ना? So and then nu and this is friction equal to ma. Correct? Same like, and now you feel ki why if you don't do laws of motion and you do this chapter you can't, because it is the application of laws of motion. So force will be equal to ma. What we have to calculate? Acceleration, na?
यस सर।
So acceleration will be equal to, what is external
सर
force?
मेरा
10.
8.27 समथिंग आ रहा है।
तो कुछ कैलकुलेशन मिस्टेक हो रही है। m1 g10 sin 30 value 1 by 2 plus new value 0.1. This and we already know will be equal to mg cos theta. Okay, so instead of n I will write mg cos theta root 3 by 2, correct, and divide by mass. Mass is 1, so there is no issue. So what will be the value? 10 minus 5. देखो सानिया, अगर यहाँ पे हम सिचुएशन देखें, like if we see here, so 10 minus 5 definitely it will be less than 5, correct?
यस सर।
So 0.1 this cancel out, 1.73. You can take it 1.72. It will be easy to divide. It will be 0.86. Correct. So 5 plus 0.86. Correct. So 10 minus 5.86. Answer will be 4.14 something. If you get 4.1 something or near 4, it is correct. Any doubt? So this chapter is really interesting because one thing for sure in this chapter, you don't feel bored. You have lot variety of questions. Any doubt, guys, till here?
No, sir.
No, sir.
No, sir.
No,
So
sir.
we'll good. Varinder and Pratigya.
No,
So we'll take 5 minute break and then we'll continue this. Okay, you can take break. So 5 minute only. So energy. Energy is ability to do work. Correct? Like basically energy can convert into work, but energy and work is not same thing. Energy is like something that we store in our body. Work is something when we are doing it. Correct? So when you are doing work, energy will decrease. When your work is increasing, energy decrease. So they're not same thing but correlated. Understood? But like work, this is also scalar quantity. Like work, it have same dimension and everything. Dimension you already know. ML square T minus 2. Correct? We have multiple energy in different chapter. In this chapter, we'll talk about the mechanical energy. In this mechanical energy, we talk about two major forms, kinetic energy and potential energy. Correct? We have sound energy, we have heat energy, light energy, many forms of energy. Depend upon what is the situation. Correct? What is 1 joule is equal to how many ERG? 10 raised to power 7. 1 electron volt is equal to how much? Anvita, 1 calorie is equal to 4.186 joule. Varinder, 1 kilowatt hour is equal to right. So these are the popular unit we use in case of energy. Am I audible, guys?
Yes, sir.
Yes,
Yes.
sir.
Okay. Next is the kinetic energy. Kinetic energy because of the motion. We have kinetic energy because we won't discuss the exact definition here, but it is the energy because of the motion. When body is moving, there will be kinetic energy. If there is no motion, no kinetic energy. The simplest formula of kinetic energy, what we do is half mv square. We can prove also this formula. and it means this is energy. So this kinetic energy is always positive. Remember this. It is a scalar quantity, and when body is moving, is having some positive kinetic energy. Negative kinetic energy is not possible. As you know, work done depend upon the displacement, depend upon the frame of reference. Kinetic energy also depend upon frame of reference from where you are measuring it. Frame of reference, right? And based on that, you can solve question. How many question we did today? 5. Question number 6. In a ballistic demonstration, police officer fire a bullet mm, of mass 50 gram. Speed of the bullet is 200 meter per second. On soft of thickness, plywood thickness is 2 centimeter. Bullet emerges with only 10% of its kinetic energy. Bullet emerges with 10% of its initial kinetic energy. Calculate the emergent speed of the bullet. Got it? This is basic question, so you have to make it fast. What is the answer? All of you got the same answer?
Yes, sir.
So, if you see, your energy is reduced by 90%, but your speed is not reducing by 90% because according to the 90%, your speed should be. Initially, it was 200 Now, according to the 90% rule, it should be 20, but it will be way more than 20, way more than. Means if your kinetic energy is reducing in the same proportion, velocity will not reduce. Definitely there will be reduction, but not in the same proportion. Correct. Next, when you do calculation, you should know how to derive something. Example, if you want to measure kinetic energy, how to measure? You know, if any body is moving, example, body is moving from A to B. This is point A, this is B. There is a total displacement D. Small displacement will be dx. You can take it as x. Otherwise, dd will be confusing. Correct. So in this case, you will say work done will be force into displacement. Angle is 0. Correct. And force is equal to ma. So it will be equal to ma dx. Correct. And you know acceleration is equal to dv by dt into dx. Dx by dt is velocity. So it will be mv dv. Correct. Now, if you integrate from v1 velocity to v2 velocity, how will you calculate? Work done is equal to integration of work done m v dv. Example, if you take from v1 to v2, what will be the value? M will come outside. M v square by 2 from v1 to v2. Can you say work done will be equal to final minus initial, right? Half mv2 square minus half mv1 square. See how easy derivations are, very logical. If initial velocity is 0, then it will be half mv square. If it is different, it can vary. But always do this common thing rather than half kinetic energy is equal to half mv square is one of the special case of this situation only. When v1 is 0 and v2 is v, right? When v1 is 0, when v2 is v, only then this is the special case. Okay, any doubt?
No, sir.
If
No,
no
sir.
doubt, solve next question. A toy rocket have mass 0.1 kg, has a small fuel mass 0.02 kg, which it burn, and this fuel mass burn out in 3 seconds. Starting from the rest on the horizontal smooth track, it gets speed of 20 meter per second after fuel is burned out. What is the approximate thrust of rocket? And what is the energy content per unit mass of fuel? Energy content per unit mass of fuel. If you calculate the thrust, what is the meaning of thrust? Basically, force upward, right? So when you calculate this force, you know force is equal to mass into acceleration. How to calculate acceleration? Final velocity minus initial velocity by time, because acceleration is equal to dv by dt. Correct? If you what you want to calculate? Thrust, force. What is the mass value? 0.1. V value, final velocity 20, initial velocity 0, so it is 20. How much time? 3 seconds. 0, 0 cancel. It will be 2 by 3 Newton. Understood? Any doubt?
No, sir.
No, sir, got this only.
If you calculate kinetic energy in this case, like kinetic energy gain,
1000.
kinetic energy. So half, what is the mass of the mass? 1 by 10, and what is the velocity? 20. 20 square,
So
400.
1000.
So it will be 20 joule. Correct? So next is the energy per unit mass. How you will calculate total energy? Divide by total mass of the fuel. What is the total energy? 20 joule. What is the mass of the fuel? What was the mass of the fuel? 0.02. So 2000 joule per kg. Tell me any doubts?
No, sir.
Done. So next, relation of linear momentum with the kinetic energy. You know P is equal to mv, correct? And we know kinetic energy is equal to half mv square, correct? If you multiply and divide with mass, can you write uh, divide by mass, multiply by mass? This. So can we say mv is equal to p? So m square v square is equal to p square by 2. And this is the relationship. Right? If it is asked in the p form, it will go to another side. So p form will be equal to under root 2m. Okay? And you use same thing in the kinetic, no, dual nature of matter, de Broglie wavelength. When you calculate, you use same thing there also. Correct? So there are different way how you correlate it. Example, case 1, if P is constant, can we say kinetic energy will inversely depend upon the mass? Make sense? This is the thing.
Yes, sir.
People will always think ki, oh, kinetic energy is equal to half mv square. It means kinetic energy always directly depend upon the mass. You should know what is the constant. Understood? हाँ प्रतिज्ञा कुछ पूछ रही थी. You were asking something.
No,
हाँ. So remember this. What is depend upon what? It always consider what is constant. Okay. Example in this second case, if kinetic energy is constant, then you know P square directly proportional to m, because kinetic energy is constant. Or if mass is constant, then you know kinetic energy will directly proportional to the P square. Correct? So graph will be different. Example, for this situation, how you will draw graph kinetic energy inversely proportional to mass? Parabola. Here it is kinetic energy, here it will be mass. Second, P square directly proportional to the m. Correct? P square is directly proportional to m. It means if mass increase slightly, P will increase a lot. Correct? P square value will be high. That's why it is like this. Understood? Here, kinetic energy is constant. Here, P is constant. And last, K directly proportional to the P square. So it will be ulta graph. Because if P increase slightly, kinetic energy change will be very, very high. In this case, it will be like this. Any doubt, guys?
No, sir.
And so next question. How many questions we have done with? 7, 8 question. Radioactive decay. You have a nucleus of radium Ra. This is 88 and 226. It decay to randon 86 to 222 by emission of alpha particle. And with energy 4.8 mega electrovolt. If the mass of randon and alpha particle you already know, then calculate recoil energy of daughter nucleus of randon 86 to 22. So focus on what is happening in the question. According to the question, you have a particle radium. Okay. When it decay, it is at rest. When it will decay, what will happen? There will be alpha particle and there is no Rn and there will be alpha particle. So what will happen? Example, if alpha particle is moving in this direction, then randon will move in the opposite direction. Both direction will be opposite. This energy is 4.8 mega electron volt. This energy you have to calculate kinetic energy. Here kinetic energy is this. Correct. So if you understand this really well, then you should also understand that we know kinetic energy is equal to P square by 2m. And in radioactive decay, there is no external force. Radioactive decay, no external force. So P external is 0. And you know F external, sorry, not P. F external is dP by dt. Second law, Newton's second law. If uh, external force is 0, then you know linear momentum remain conserved. It means linear momentum is constant. If linear momentum is constant, can we say m and k will be constant? 2mk will be constant. Makes sense? Because 2 is fixed value constant, p is fixed value constant, then can you say mass and kinetic energy will be constant? Yes or no, guys? Yes or no? So if this is the situation, mass of the random, kinetic energy of random will be equal to mass of the alpha particle and kinetic energy of the alpha particle. You have to calculate kinetic energy of random. Mass of alpha particle is approx 4, kinetic energy 4.8 electron volt. For random mass is 222. You got answer. Was it really difficult? You
Awesome.
applied their relationship K is equal to P square by 2m. You applied last chapter formula when radioactive decay, external force constant, so linear momentum conservation of linear momentum. If this is the situation, you will come up with the final formula. Mk will be constant. Mass and kinetic energy relation will remain constant. Okay, and you can get answer. Anybody have doubt in this question?
Not so.
No, sir.
Good. So next, very popular but one of the most easiest equation is work and energy theorem. This question was 8th. Work energy theorem. And the interesting part is we are already done with it. Work energy theorem. How? Remember in this work energy theorem, one of the most popular theorem, when you apply F4, a constant force on a given mass, there is acceleration, it will cover some distance with some velocity. Then there are two ways to do this. One is example, v square minus u square is equal to 2as. If you multiply with half m in every situation, multiply with half m, doesn't make any difference. So this side it will be half m v square minus half m u square is equal to half m 2as. 2 will be cancelled out. I will write it. 2 will be cancelled out. MAS, and this is equal to force into displacement, and this is also equal to work done. Correct. This is the final kinetic energy. Initial kinetic energy is equal to work done. Yes or no? Any doubt? You can also do the same stuff using this part. This is the same thing. V2 is final kinetic energy. V1 is the initial kinetic energy. Right? Here, everything is same when you calculate the work energy theorem. We calculated work is equal to half mv square from initial to final value. Initial is u, final is v. Correct? It can be also equal to half mv square minus half mvu square. Same thing from the previous equation. That's why I said we are already done with this. Any doubt?
No, sir.
If you don't have any doubt, then write question number 9. One 8 kg block initially at the rest. So you have a block of mass 8 kg at rest. Is pulled to right along with the frictionless horizontal surface. So you have frictionless surface and there is a constant force of 12 Newton acting on it. Find the velocity of block after it moved to the 3 meter distance. Velocity after 3 meter distance. And also find out the acceleration. Work done is equal to force into displacement. Force you are applying 12 Newton. Displacement is 3 meters. So it will be 36 joule. Correct? This is the work done. Then if you see final kinetic energy will be half mv square. You have to calculate this. Initial kinetic energy half mu square will be 0. Why? Because initial velocity is 0. Initially it was at rest. We know work done is equal to K final minus K initial. K initial is 0. So work done is equal to K final. What is the work done value? 36 joule. Half. What is the mass value? 8 kg. And velocity you have to calculate. So what will be the velocity value? 3 meter per second. Yes or no, guys?
Yes, sir.
And you know V square minus U square is equal to AS. U square is 0. V square will be 9. 2A. You have to calculate S value is 3. So what will be the A value? 3 by 2. Yes or no?
Yes, sir.
Well, anybody have doubt in this?
No, sir.
No, sir.
This is when force is constant and overall work done is constant. But you can calculate variable work done. Correct? There could be variable force also or displacement also. So you calculate variable work done. So it will be same. Final kinetic energy minus initial kinetic energy. Work done could be also do F dot dx from initial position to the final position. Correct? Same thing. I just wrote work done into the front form. Understood? So this is the work energy theorem again, but for variable force. Okay. So if you understand this, write next question. 10. Consider a drop of small pebble of mass. You have pebble and each pebble of mass 1 gram fall from a height 1 kilometer. It hit the ground with the speed ground speed 50 meter per second. What will be the work done by the unknown resistive force? So you know they are dropped. So U value will be 0. V value is 50. Mass is 1 gram. Height is 1 kilometer, so 1000 meter. Correct? And in this case, if you calculate change in kinetic energy, it will be the final minus initial. Final is half mv square. Initial is half mu square. And you know initial is 0. Correct? So change in kinetic energy is equal to half. Mass is 1 by 1000 because 1 gram. And velocity is 50 square. 50 to the 100. 0, 0 cancel. So 5 by 4. The change in kinetic energy is 5 by 4, 1.25 joule. Correct? And we are assuming if G value is fixed, then work done because of the gravity will be force into height. Force will be mg, h. Correct? So what is the mass? 1 by 1000. G 10 and height 1000. What is this force? 10. So because of the gravity, there is a force of 10 joule. But kinetic energy we can see 1.25 joule only. So what is the remaining force? It will be friction, right? If you see total kinetic energy change, it will be equal to the weight because of the gravity and the force because of the resistance. If you calculate force work done because of the resistance, how will you calculate? Change in kinetic energy minus this. This is 1.25 minus 10 minus 8.75. Yes or no, guys?
Yes, sir.
Let's do last question of the day. How is it going as of now?
Good, sir.
Everybody,
Good, sir. Yes.
I am enjoying this process because we did good amount of question, like one topic, one question, one topic, one question. And last question of the day, how many questions? 10, 11. You have a block. Block mass is 1 kg. Okay. Moving on a horizontal surface with the speed, initial speed of 2 meter per second. Enter into the rough patch. Enter into the rough patch from x 0.1 meter to x 2.01 meter. Retarding force on the block is inversely proportional to the x over the range. So retarding force is equal to minus k by x 0.1. X value is more than 0.1 and less than 2.01 meter. Correct? K value is equal to 0.5 joule. What will be the final kinetic energy? Anybody got answer? You have to calculate final kinetic energy, and you know final kinetic energy minus initial kinetic energy is equal to the force into displacement from x initial to x final. Correct? You can calculate what is the initial value of the initial kinetic energy. Half. What is the mass? 1 kg. What was the speed? 2. 2 square 4. So initial kinetic energy will be 2 joule. Correct? So if you calculate final kinetic energy is equal to K, I will go to other side 2. Right? Any doubt?
No, sir.
So plus it will be integration from 0.1 to 2.01 of what was the value? Minus K by X. Right? This was the force value, resistance force value. So how to calculate? 2. K can come out and K value is 0.5. So minus K 0.5. 1 by X, if you integrate, what will be the value? Natural log X? Yes or no? From 0.1 to 2.01. Correct? So now you can put the value of this 2 minus 0.5. Natural log X value will correct. So it will be like 201, 201 by 100 by 1 by 10. This cancel. So it will be like 20.1, right? Yes or no? Natural log 20.1. So 2 minus 0.5. What is the natural log 20.1? If you convert with the in the form of log approx 20. What is the log 20 value? Log 10 value is 1. 2 value is 0.3, right?
Yes, 0.32, I think.
So it will be 1.3.
So close
Correct?
to negative 1 joule, no?
Correct. What?
So I got my
Log
answer
20
close to
value will be
-1.
1.3 now. Then you can calculate. Remember one thing, if you integrate dx by x is equal to natural log x. This is really, really good. Everything else is easy to do. Why? Because you have to apply variable force work energy theorem. Put initial value, you will get, and this force value is minus k by x given in the situation. Everything else is normal. You should know natural log x will be equal to 2.303 log x. And I guess all of you know that, right? Natural log x is equal to 2.303 log x. Correct? You will calculate final value of kinetic energy. From that you can calculate speed. Any doubt?
No, sir.
Hmm. Because if you want to calculate speed, how will you do? Final kinetic energy is equal to half mv square. So v will be 2 kinetic energy divided by m under root. We will get final k value from here and then put mass value is 1. Then it will be easy. What will be this calculation? If you take, it will be approximately 0.5 joule. If you take 0.5 joule, it will be equal to 1 meter per second. Anybody have doubt the question?
No, sir.
So we are done with the kinetic energy, work energy theorem. We are left with the potential energy. Motion in the vertical circle. You had question na, in the circular motion, last test, difference between the tension. We will discuss in this chapter. And other than that, power and collision. So potential energy, power and collision. Three topics we are. Power is a small topic, extremely. Main topic is collision. You get question every year from collision. Pakka. Extremely important. Tell me guys, any doubt?
No, sir.
So first all of you send me